Okay, so graphs of polynomial functions. Now, I know you guys love graphing things so much, so we'll try and get through this as quickly as we can. Now, we're going to just be looking and focusing on a few different aspects because you guys should know how to graph a lot of things already, okay? And I'm just going to go over a few things and throw in a few tips too that might just sort of go, oh, like I didn't realize that was the case. So suppose that we have a polynomial that's at least degree 1 and the leading term is a n to the x to the n. Now, if this term here is at the front, as x approaches infinity, this term and this term at the front is positive, then what happens is my function, p of x will also approach infinity. So basically I'm saying if this is positive, the longer I go this way, the higher up I'm going to get, so something like that, okay? However, so that's if it's positive, but if it's negative, then my p of x will actually go the opposite direction, okay? So basically, the further and further we go out this way, my graph's actually going to start to go down like that, okay, in some way, okay? So that's like cool fact number 1, okay? And I might just redraw that one. So we'll have the Cartesian, so as x goes this way, okay, blue for positive, goes like up, something like that, and red for negative goes down, something like that, okay? So the graph is going to go one way or the other, depending on what it does. Now, if x approaches negative infinity, so, where's my black? So, as x approaches negative infinity, so if we're going the other way, it basically does the opposite. So if the term out the front here is positive, then it's going to go this way, and if the term out the front is negative, then it's going to go this way, okay? But that's only the case when our power is, when the power is odd, okay? So if we have an odd power, okay, and we can test that too by checking some points. So for odd powers, okay, and I'm going to write p of x approaches negative infinity, so it does the opposite, and that's positive, and p of x approaches infinity, and that's for the negative ones. And it looks like I've just written positive again, so I'm gonna, okay, and we can test that too. So let's think of the polynomial. So like p of x is a really good one. P of x cubed is a really good one. So if we substitute some values in x cubed, okay, so I put in, so let's say x is equal to 10, so then that's 1,000, x is equal to 100, like it's getting really, really, really big. But if I substitute, say, like x is equal to minus 10 or x is equal to minus 100, okay, it does the, or 1,000 even, it does the opposite. Like we're going to get this, and I can use the calculator for this one, so if I go minus 1,000 and I put it in cubed, it's going to give us a massive negative number, so it's going to be really, really, really low. Okay, now that happens with odd powers. Now, for negative powers, for even powers, God, I can't really draw infinity signs, can I? For even powers, okay, it's going to basically do the same as, so as that happens, so as x approaches negative infinity, p of x is going to approach infinity if it's positive, and p of x will approach negative infinity if it's negative. So in other words, it's basically going to do the opposite of this. Now think of a parabola. So a parabola, x squared, nice and easy one. So if we had p of x is equal to x squared, if I was to sketch that, okay, really quickly, we know that it looks like this, okay. So as x goes this way, it's going to get positive and positive and positive, but as x goes this way, it also gets positive and positive and positive, and that has to do with the fact that we have an even power up there, okay. So that's a really quick trick. And every polynomial of degree 1 has at least one zero, is the third thing that we need to talk about. So the zeros. So if the polynomial can be factored, then its zeros can be read off very quickly, and we can construct a table of values to test its sign, okay? So let's say we have a quick polynomial. It's like p of x is equal to, I don't know, x plus 3, x minus 1, and x plus 2. Okay, so you've got a polynomial like this. We can quickly read where the zeros are, okay? okay, because we know it's when the equation is equal to 0. So the 0 is going to be when x is equal to minus 3, x is equal to 1, and x is equal to minus 2, okay? So that's where the zeros are going to be on our equation, and what it means is, if I was to sketch this, okay, at minus 3, at 1, and at minus 2, okay, my equation is going to cut through these points here, okay? And we don't know which way it's going to go just yet, but it's going to cut through those points. So if I was to actually draw this a bit nicer, okay, because we can do this all in one big go while we're here. So go here, come on, there we go. And go here. Okay, so let's go up 1, 2, 3. 1, 2, 3. Okay, so one of the points is here, one of the points is here, and one of the points is here. So those would be the 3 values for which my function exists. Now, if I was to extend this out, this function out, we can use the fact from yesterday about the multiplying with the degrees. We're going to find out that this is going to be a degree 3 polynomial. So that means that as x gets bigger and bigger this way, okay, our value of our function is going to get bigger and bigger that way. And because it's an odd function, the smaller and smaller we get, our function is going to become negative and negative and negative. Now, what happens on the inside is a little bit different, okay? So, what we can do is we can actually work out what what's going to be happening in between these by a few ways. Okay, so we know that this point here is 3, this one's 2, and this one's 1. What we could do is we could test a point within either of the, we could test a point inside each of the boundaries, because we know it's going to pass through here some way. It's either going to go like this way, or it's either going to go like this way. Okay, we're not 100% sure, but what we can do is we can say, let's test the number in between, so 2.5, substitute it back into this equation up the top here, and that's going to give us a positive or a negative value, okay? So let's try that. So 2.5 plus 3 times 2.5 minus 1, okay, times 2.5, and these should be negatives, not positives, by the way, because I'm silly, plus 2, and let me go and put negatives in here when I close that one off. Negative and negative, and we get 7 and 8. So that means that this one is going to be like this tall. So what happens is this function goes up to here, and it's going to come back down here. Okay, then we're going to say to ourselves again, well, what happens in between 2 and 1? Okay, well, let's substitute the values in again, and let's pick a number between negative 2 and 1. I'll put negatives there because it keeps confusing me. So what happens between negative 2 and 1? Well, it'll go past 0. So let's substitute 0 in. So I'm going to get 0 plus 3 times 0 minus 1 times 0 plus 2. Okay, and so what happens is it's minus 6. So at 0, it's probably down, like really far down. So it's going to come like here. And then it's going to come back up like this before it keeps going on like that. So something like that. Okay, and that would be an appropriate sketch for p of x is equal to x cubed, lots of x minus 1, lots of x plus 2. So x plus 3, lots of x minus 1, lots of x plus 2. Okay, so sometimes when you have a polynomial, it's not going to be as nice as that. Sometimes a polynomial might look something like this. So if this is the case, we've got what's called double and triple roots, okay? And we know it's double and triple roots because we've got the double root here and the triple root here. So if I was to extend this out, it'd be like x plus 2, lots of x plus 2, lots of x minus 3, and like so on. You get the picture, like it's all of them together. Okay, now these double roots are going to do something for our graph, okay? So what it's going to do is it's going to actually determine what our function is going to do, like in the middle points. Now, so if we have a look at, well, let's do the above function that we've got. So I might do this properly again. Okay. So if we've got a double, okay, so let's find out our zeros really quickly. Minus 1, minus 2, and 1, 2, 3. So they're going to be passing through here. Again, we're going to work out what the power is. So this one is 2, so 2 and 3 and 1 is 6. Okay, so even power means that, and it's a positive because it's only a 1 out the front, so it means that this one's going to come up like this, and this one's going to come up like this, okay? So because it's an even power, they're both going to go in the positive direction because we have a... So if this was like negative, lots of this, then they would go down. But because it's not negative and it's in fact positive, they're both going up. So what we can do is we can check what's happening in between again, or we can use the fact that we've got these double and triple roots. So if we have a double root, what happens is our function is essentially, when it gets to that point there, it's going to go back up, okay? It's going to go back up because if you think about when you're squaring something, so say like any number, when you square it, it's always going to be positive because, you know, like two numbers multiplied by themselves will always end with a positive number. So this one on this side here, around the 2, it's actually going to pop back up before it comes back down for the -1, where it's going to hit that root again. Now, the 0 at 1, so this part of my polynomial here is only got a power of 1. Now, because that's an odd power, what that means is this one is going to come down like this until it gets to some point down here where it turns back around and it's going to hit the 3 like that, okay? It's probably not going to exactly look like that, but that's what it's going to do, something like this. Okay, and then we get up to 3. Now, because we've got the 3, it's an odd power, okay? So it's an odd power. Because it's an odd power, it means it's going to jump over the other side and it's going to keep going up like this, okay? So if it's even power, stays on the same side, or an even 0 stays on the same side, and an odd power jumps across. So like it did there and there. So what we're going to do quickly is we're actually going to check out Desmos and see what they reckon. Of course, we love a good Desmos. And we're actually going to put in this function that I've got here. So that is y is equal to x plus 2 all squared. And look at that. You can see where that parabola is. So if I go back to mine, you can see I've got this parabola sort of starting over here. Like it's sort of starting this parabola here. It's not exactly a parabola because we know it's there's some other stuff behind it, but you can see the start of this parabola down here, and it sort of pops up again this way. Okay, so going back, our next bit is x minus 3, and that's to the power of 3. Okay, so as you can see, we've got this guy going here. So this one's flipped this one, but remember we've still got one more term to put in, which is the x plus 1. And have a look at that. You can see it's obviously not exactly the same because it actually shoots right up to 12 to mine. So if I can't really do that. If I close this one and I put it next to ours, okay, you can see that I've sort of got the same shape. Like it's not exactly the same. Like obviously it's much more steeper, but it comes down here. Okay, so it comes down here, turns back around to go back up to a top, and then it comes back down through -1 just there. Okay, so -2, -1, comes down, 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 and it's going to come very far down till it hits this point here. So that's whatever that point is. I'm not sure what that point is. And then it's going to come back up, hit my other 0, so the 3, 0, so this point here, and it's going to do like a little... I haven't really drawn it, but like a little bump, and then it's going to come back up. So you can sort of see where all of the shapes are. So like, you know, you've got this parabola here, you've got this cubic going down this way, and you've sort of got your straight line here, kind of. So with that being said, that's pretty much everything that we need to know. I'm just going to quickly read through a bunch of other stuff. I'm just going to bring this over, actually, and we'll just quickly read through it. So we've got multiple zeros. So that's what we were just talking about then. So if you have more than one of them, then it's called multiple zeros, and the multiplicity of that is just how many there are. So if we go quickly back to this one, our multiplicity of like this bit here is 2 because that's how many times it appears. The multiplicity of this bit is 3 because that's how many times it appears. The multiplicity is 1 because there's only one of them. Okay, so that's what that means. A 0 of multiplicity 1 is simply called a 0, or called a simple 0, and a 0 of multiplicity greater than 1 is called a multiple 0. So that's just basically what we said. And then this is what we were talking about before, about the shape of the curve, okay? So, like, that's the really, really quick way to sketch these polynomials. You're not going to really do them to scale, but if you just follow those factors, the fact about, you know, like what happens around each 0, like is it a positive power, is it a negative power, is it an even power, or is it an odd power? If it's even, it's going to go back up. If it's odd, it's going to sort of keep going in the direction it was going. Okay, so with that being said, that's the end of this part. That's the end of the graphs. What we're going to be doing after this is going to be dividing some polynomials. Actually, you know what? I almost got ahead of ourselves. I've got some examples of sketching some of these, but we might just focus on one really quickly, and I will put the other two up at a later date. So let's sketch the following, because we have already done one of these, but you know, if you just had the question said, sketch the following showing the behavior in any x-intercepts. Okay, so we'll start with p of x. Okay, so what I'm going to do is I'm going to draw up a Cartesian plane, and my two roots I quickly can see are at 1 and at 2. Okay, so those are my roots. Now, x minus 2, so this one here, is it a positive or a negative? So as you can see with this one, it's positive because there's technically just a 1 sitting out there, but this one down here has a negative out the front. So because this one has a negative out the front, it's going to basically do the opposite of what we said. Now, the degree of this polynomial is 2 plus 1, so it's 3. So this is degree 3, okay? So if it's degree 3, that means that it's going to go up this way, but it's going to come down this way at some point, and it's going to do it in one way. Now, at the root x of 2, so the x minus 2 squared, because it's an even, so this bit here is even, that means that this bit's going to come back up, and then it's going to come back down again like that, and that's pretty much our sketch done. Like, that's literally it, because the 1 is odd, okay? So when it comes back down, it's going to continue coming down like that, and like that's it. Like, it's really not that tricky. If I quickly jump back on the Desmos, look, here we go. I'm going to put in y is equal to x minus 2 squared, with a squared on the outside, not the inside, and then x minus 1. Look at that, you can see that. I'm going to have to zoom in for this one, but look, that's pretty much what we've got, except obviously my bump's a bit bigger, so if I was to do it properly, it would be like, oh, go away, it'd be like that. Okay, you can see that too, like, that's it there. That's all we need to do to sketch these things. In fact, you know what, we'll do q as well. Q of x, so that's part A, this is going to be part B. So q of x, and I might bring this one down a bit more than the other one. Okay, and this one is, okay, so we've got a lot of roots in this one, so we've got this part here, where it's equal to 0. So the root for that one is equal to 0. The root of this one is minus 2, so that one's minus 2. And we've got a couple of roots in this one here. So two numbers that add to 1 and multiply to give to 2. Sorry, add to minus 2, multiply, give, give 1. Should be minus 1 and 1. No, sorry. It's going to be neither. It's not going to neither be minus 1 or positive 1, because minus 1 and minus 1 would make a positive 1. So that one doesn't actually have any roots. So we're going to ignore that bit, and we're just going to focus on the 0 and the minus 2. So at 0 and at minus 2. So at minus 2, okay, it's a cubic, and this is a positive 1, so it's going to come from this way, okay, and it's going to come back out this way, so in some way, shape, or form. Okay, and because we've got the even and then an odd, so the even one's going to come back down this way, and then the odd is going to make it come back up this way before it continues going on that way. Okay. So again, quick another look at Desmos, because it's very easy to. I'm going to quickly just scroll up. We've got y is equal to x squared, x plus 2, all cubed. So there's that bit there. That's our main bit, which we drew up. But what you'll notice is if we put this other bit in, it's just going to sort of increase some of the details quite a bit. Okay, so as you can see, it's sort of... Oh, why have I done it on the positive? It should be on the negative. Oh, hang on, no. It's this one down here, isn't it? So as you can see, it sort of just does stuff to this bit down here. But the main bit we're going to be focusing on is what's happening at these zeros and what happens from there. Actually, oh yeah, here it is up here, back up the 2. Oh, there is a 2. Hang on. That one's a little bit odd and not doing quite what I wanted. Oh, because minus 1's outside, not inside. Duh. There we go. Okay, so there's our minus 2. There's our 0 over here. It looks like we've got a... Oh, can we actually do roots for those ones? Hang on, let me think. Minus 2. Minus 1. No, I can't think. It must be something that does it. Anyway, with that being said, we might leave that video there on the note where it's where I've made all these little mistakes. But again, if you were to do part C would work perfectly fine. Okay, so with that being said, that's the end of the graphs of polynomial functions. I'll leave that to you guys to do now, and we're going to be looking at division in the next topic. Ciao.